Hello there, I'm back from season number 1 to season number 2. It's been a great journey from season number 1. You, all the viewers, all the subscribers, a very warm thank you. And basically, I will like that you love my channel and just try to aware people about my channel and keep on sharing it, commenting, liking, subscribing. So many things to tell. But as we always say, the journey always continues. So we are now here in the season number 2 of Electronic Technocrat. So whatever will be your doubts, and if you want to contact me, the email ID will be given to you in the main page of the YouTube channel. So you can visit my YouTube channel and see that there is an email ID provided there, or the mobile number will be provided to you there, or you can directly contact me in the comment section on whichever topic you want to be explained or to be performed. That will be performed as soon as possible by me. And now here we end our introductory session. Now we'll move on to the one of the most important, the most popular, the chanting topic of the current generation right now. And that topic, any guesses? Let me give you a hint. It's an IC. Keep on guessing. There are hundreds of millions of ICs there. You might be guessing which IC I'm going to be providing right now. So no more suspense, so let's move on. The IC we are going to decide, or we are going to speak about in today's tutorial, will be IC 555. Oh yeah, the 3 times 5, the triplets. This is one of the most popular and the most widely used ICs in the industries or by the students like us, and for also very small scale project levels. Why is it used? Now you must be wondering about why we are using this IC so popularly, or why is this IC so much demanding nowadays. Just because it has some very good features, like it's a versatile IC, it can perform many functions, it is extremely robust, and it can be used in the applications like the timers, the pulse generators, the oscillators, and blah blah blah. Damn, there are so many things about this IC. This IC was basically brought in 1971 by the Signetic Corporation and by the person who invented this IC, named as Hans Kamenzind. Nothing to tell about it as more as possible. So it was released in 2 parts basically by Sir Hans. The 2 parts consisted of the initials called as the capital N, the capital E 555, and the capital S and the capital E 555. The NE 555 parts were used in the commercial uses, and the temperature range of those ICs was around 0 to 70 degrees Celsius. And the SE parts were designed for the military standards to the range, and the use of that range was minus 55 degrees, like extreme cold weather, to 125 degrees to a slightly boiling temperature. So it's kind of a monolithic IC and was first commercially available timer IC. Well, I am emphasizing on this word timer here. You will come to know why I am emphasizing this word timer in the video after this. So first of all, before moving up, we will be looking about some very important features. Why is IC 555 so demanding? IC 555 has a very wide operating range, that is from 5 volts to about 18 volts. So right from the normal power supply to a very high power supplies basically. The second uses of this IC would definitely be its high output current capability. Output current. Well, we need not to go in the detail of this topic. The third possibility why are we using this is it's compatible. It's TTL compatible basically. Again, I'm telling you this is not very important. So basically these are the main features why the IC 555 are basically used and are so popular among the student use, or we can say the large scale industry or the small scale industries, and blah 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 blah. This IC is my favorite IC, and that's the reason why it is so. Now you guys will be thinking, what about this number, right? What is IC555? And I told you about what is IC555, but I didn't tell you about what is the 555 and how did it come from. Well, basically I will tell you about this 555 in the next 2 minutes. You will be understanding why exactly I am emphasizing on this 555 word and how has it been derived, basically. Alright, so without wasting any time, let's move on to the pin diagram of IC555. Well, one of the most important thing about any IC, it's its pin diagram. As you can see, most of the ICs are about 16 pins, or we can say 32 pins or 40 pins or 80 pins and so on. But IC555 is an 8-pin IC. Alright, so we will study each of the pins and their functions one by one. Alright, so without wasting any time, let's go on to the function of the first pin, that is the ground pin. What is the ground pin? Yeah, exactly, you're correct. Ground pin is used for ground reference voltage. Basically, the ground reference voltage is basically 0 volts. It is used to sink the current, or we can say the source the current, basically. Or we can say it is also used for earthing the device so that it can be saved from harming, or it can be saved from burning the device. The second pin is the trigger. What does the trigger pin actually says us? It is responsible for the transition of the SR flip-flop. Everyone knows what is SR flip-flop, right? So I need not to waste any time on SR flip-flops right now, or if you want, you can write in the comment section if you want SR flip-flop to be explained in detail. Alright, so the next pin, or the information about the pin number 3, is the output. As we all know, every IC has got an input and that IC also gives an output. So don't stress your brain about this pin. It's only the output pin, that is pin number 3, and this pin only gives you the output, and the output depends on the input always. So that's dependent on each other criteria. So basically the output is completely dependent on the input. The fourth pin is a reset pin. Any negative pulse on this reset pin will basically disable or reset the timer. You might not understand what I'm trying to tell you now, but it will be very much crystal clear in the next slide, which I'm going to be explaining you in the next 2 minutes. The next pin is the pin number 5, that is the control voltage. This pin is basically used to control the width of the output pulse by controlling the threshold and the trigger level. Oh, that's a bouncer. And just remember one thing, like if we have a square wave here, alright, what you can see in the square wave is, what is this called as? It is called as the width of the pulse. Alright, this width is been controlled by this control voltage, basically, and this width is what we obtain in the output. And what is the pin number of the output? Exactly, the pin number of output is pin number 3. Okay, so now we move on to the pin number 6, that is the threshold pin. This pin basically compares the voltage applied at the terminal and with the reference voltage, that is 2/3 of VCC. Well, another new term, what is this? As I have told you just a minute before, you will get to know this in the next slide, so don't stress your brain. 2/3. I will also tell you how this 2/3 also came. The next pin is the pin number 7, as a discharge pin. This pin is connected to the pin, or we can say the collector of the transistor. Now everyone knows what the transistor is. Okay, if you don't know, not a problem. I'm gonna draw this transistor for you. So this is a transistor. This is an NPN transistor, and this is basically the collector, and this is basically the emitter, the collector, and this is the base, the EBC criteria. So that's how I actually remember it. So this is a transistor, but what type of transistor is it? It's an NPN transistor. How do I know it? Look at the arrow position. When the arrow is outwards of the transistor, or when it is going down the emitter, it's always the NPN. And when the arrow, I don't have any space, so let me erase this up for you. So when the transistor is drawn like this, the arrow is inside or is going through the transistor. This is the collector, this is the emitter, and this is the base. So this is called as the PNP transistor, because the arrow is very important here. The arrow is going inside the transistor. When the arrow is going outside the transistor, it is called as the NPN transistor. That's perfect. So now you're a champion of electronics. Doesn't matter which department you come from. Now you are a champion in remembering, or we can say identifying, the transistors right now. So anyone who asks you in the interview questions, you will be able to answer these two questions very easily right now. Okay, so the 8th pin now is the VCC pin. As we all know, every IC needs an input, and or every device, not an IC or any IO device or any kind of device, needs an input, and so that it can generate an output basically. Okay, so the input basically is here is the VCC. Alright, this is called as VCC, or we can say the pin number 8. So pretty much clear about the pin diagram of IC 555.